Hello and welcome everyone. So I'll be trying to explain a very interesting problem. Um, Codeforces round 856, Division 2, problem B named Not Dividing. Basically, in this problem, you're going to be given an array of n positive integers, and um, you're going to have to output a certain amount of a certain array result where the constraints would be that no adjacent elements are divisible with each other. What I mean by is that, let's say if our array is of length like this, final output of the array should have the following constraints where the ith element here will not be divisible by the immediate previous value, and it should maintain in every possible index starting from I equal to 1. And so that's the output that we need to generate. But there's a catch. The catch is that initial array won't have the characteristics, but you can actually come up to this conclusion by following some operations that you're going to be given, or should I say you're allowed to apply those operations. What are those operations here? Um, let's take a look at these operations. The operation is that uh, you would just increase you have the independence of increasing any value of a particular index of the array. Just add 1 to it. You have the ability to add 1 to what it was before. What I mean by is that let's say this element was 5, you can just draw an operation and it's going to be 6. Or let's say you want to do again an operation 2 times and it's going to be 7. Okay, so you're going to just add 1. But you're only allowed to do that only 2n times. So if I say so, it will be you can maximize at maximum you could only add 2 to the power n overall. So what I mean by is that you cannot add more than 2 to the power n. After that, you won't be allowed to apply the operation anymore. So you're allowed 2 times n operations, where n is actually the length of the array itself, and you, uh, yeah, that's the constraint of adding numbers, or should I say, to come up with the conclusion. You can do that, but there's a constraint up till 2 times n. And that is very important here, This 2 is very, very important. Now, why it's important, I'll come up to that later, but now imagine what would be the answer. Initially, what sort of solutions could come to your mind? What I had in mind was that, okay, first of all, I will check whether any of these adjacent elements are divisible or not. Whether any of these adjacent elements are divisible or not. If they're divisible, whether any of these adjacent elements are divisible or not, I'll check whether AI is divisible by AI minus 1 or not. Um, if they are if they are not divisible, I won't do anything to the array, anything to the particular index. If they are divisible, then what I would do is simply increase these AI number by 1 and apply 1 operation. And it's obvious. It is very, very obvious to think about it like that. Let's say 4 and 2. We've got 4 and 2, right? 4 and 2. Okay, I'm seeing that. Okay, 4 is divisible by 2. What am I going to do? Just increase it by 1. And what it's going to look like is 5. And then if come forward we've got another number like that, let's say 10 is after 5, I will check, okay, is 10 is divisible by 5? Yes, it is. Then increase 10 by 1, 11, and so on and so forth. Yes, we can think about it like that, but that's not going to be the ultimate solution here. Why? Because in the constraint here, we've got 1, and 1 is going to cause a terrible one is gonna cause a huge conflict and problem regarding this obvious usual solution. Now we need to tackle this problem of one. Now you might be saying why one is getting or causing the problem. I'll Let's draw a test case uh, you know uh, to see why one is actually the problem. Let's say our array initially is given like that. What are we gonna do? Simply the same obvious solution. Okay, whether this is divisible by this, yes, it is divisible by this, then increase it by 1, then 1 becomes 2. Secondly, okay, are these things divisible? Okay, 1 is not divisible by 2. Okay, everything is good. What about here? 1 is divisible by 1. Okay, that's cool. So I'm gonna increase this thing by 1, right? I'm gonna increase this thing by 1 and it becomes 2, but in doing so, our array does not fulfill the condition here. Why? Because in here, you know that we've increased that 1 by 1, which means 2. So now the ultimate array is 1, 2, 1, 2, but it's not fulfilling the condition. Why? 2 is divisible by 1. Here, there might not be 1 divisible by 2, but 2 is divisible by 1 again. That's not the solution. So it's not fulfilling the constraint. So, and that's where the help comes here. We can apply 2 times n operations, and that's exactly what's going to help us. So on an average per index, you can increase a number by 2. You could say that, right? You could say that. But what we're going to do, a very easy solution for that. We have an easy solution to that, as we're allowed to apply 2 times n operations, not n operations. What we're going to do is we are going to get rid of all the ones. That's exactly what we're going to do. If there's any one here, initially we're going to check. If there's any one available, just increase it by 1. It becomes 2. And now the solution after that, the solution is solution is absolutely easy, because it's going to be the same obvious previous solution that I was talking about in the first place, which was just take a look at the adjacent ones. If they're divisible, just add 1 to it. Take a look at whether they're divisible or not. If they're divisible, just add 1 to it. That's it. That's the solution here. Check out the ones, increase it by 1. That's the first loop. And then after that, do the obvious initial first solution, and the answer is going to be just like it's going to come to the result will be the correct one always. And so if I take a look at the code section, it's very easy. You would easily implement that, and yeah, that's the ultimate solution here. I hope you would get the intuitive perspective of this particular problem. So yeah, thank you very much for listening. Till next time, goodbye.